Nageswara Rao, and this is pre-recorded. So, over to you, co-host.
My name is PSRK Nageswara. I work as an associate professor in the Vasavi College of Engineering, Nagamodu, Vizayakumar. So I am going to deliver here my topic is modeling the manufacturing enterprises, a systems approach. And my guide belongs to the Bapatla College of Engineering as an advisor there, and my co-guide belongs to the Usmania University. Yeah. So coming to the introduction, the present manufacturing industries are challenged the intense global competition characterized by changing the customer requirements. During the last decades, the manufacturing enterprises have pursued the cost reduction problem without compromising the quality of that particular component. The main reasons to the investigation of the manufacturing the systems has to be understand, analyze and control the non-linear behavior of the processes. Yeah, the objectives of this particular research work is understand the context of the problems of the manufacturing enterprise and the internal dynamics, and primarily through the modeling by the process of its operations as well as the activities. The second objective of my research is attempt to provide the deep understanding of the structure and internal mechanism of the manufacturing enterprises by the step by step, and how to understand the dynamic behavior of the systems. The third objective is to discuss the system dynamics model in detail and present the insights gained by the research running the simulations. Yeah, coming to the methodologies, I am using the system dynamics methodology here. The structure defines the variables where we interact with the one-to-one, and the causes the dynamic behavior. The behavior of the business processes, the functions of its characteristics. The process is functioning the characteristics of the system and requires the redesign such a process and requires the concentrate the rethinking of those structures. So mainly we concentrate on the system dynamics. The heart of the process is the feedback systems, which is concentrating on the structure rather than the variables. And also we have to concentrate on the what are the delays are incurred in the particular process, and we have to find out what is the causes for the observed deviations. And third one, we have to go for the symptoms. What is the real causes of the particular system, how it is acting on that, we have to see that. So here there are the variables are used in the particular quantitative analysis. So see this particular causal loop diagram. The causal loop diagram, PPR means production, means the parts production rate, and the parts production rate and increases, the working process inventory is increases. The working process inventory increases, the assembly rate increases. Then our assembly rate increases, obviously the finished goods inventory is increases. The finished goods inventory uses what is the correction, or what is the difference between the discrepancy between the required and the demand will be decreases. So that will be, if it is increases, the parts production rate increases. This circle, the cyclic nature indicates that parts production rate to the working process and the assembly rate, and assembly rate increases, the finished inventory increases, the initial inventory increases, the correction is decreases. Once the correction is increases, and again parts production. This is one of the negative loop, and moves to the diagram, and one more negative loop is there. Here working process is increases. Here the working process increases, the assembly rate will be increases. If the assembly rate increases, obviously working process will be decreases. This is the second loop, and now moves to the third loop. Here this one, the third loop is once the assembly rate is increases, the finished inventory is increases. The finished inventory is increases, then the assembly rate will be increases. This is third negative loop, and moves to the it moves to the positive loop. one you observe here, and the same cycle the up to this one the sales rate is increases and the assembly rate is also increases and the post production rate is increases. Means this indicates that the post production rate increases, that the PPR means the post production rate increases, the work in progress is increases, and work in progress increases, and this particular assembly rate is increases. Once the assembly rate is increases, finishing goods are increases, and sales rate is also increases, and all are simultaneously increases. So this is the description of the particular model in the conceptually in the quantitative analysis of the. We have to find out what is the reason for the variables, the difference between the variation between why the variable is affected the another variable we described in the causal loop diagram. This is only where the qualitatively we analyze this particular process. But moves to we have to the quantitative process. Again, the same model we have to convert it into the I think package is there, that is the Stella package. In that we have to make the stock flow diagram. This the thick lines indicates that the material flow, and the rose color lines indicates that the what is the information flow. This line indicates that the material flow, and this line indicates that the information flow. And here there are three types of the variables are there. One is the rate variable, this is the level variable, and this is the rate variable, this is the auxiliary variable. So here this is the stock, means the work in progress is a stock variable, and how much stock is available in this particular line. And moves to this finished goods line indicates that this is also known level variable, and this here this will be rate variable is the inflow and this is the outflow. Coming to this level variable, this is the inflow and this is the outflow. So this is the material flow line, and remaining all these lines are indicated that the information flow. This remaining this particular symbol indicates the auxiliary variable. So this is the information is separated to this what is the rate variable. The rate variable will be changes automatically. The what is the level variable will be changes. So we have to go for the mathematical relationship of this particular. This one is. So coming to the desired production rate will be calculated with the average shipment rate plus initial inventory correction. Then assembly rate will be calculated by the work in process inventory and parts supplied rate. These are some of the mathematical calculations we have to do. And coming to the results. So the time to correct the finished inventory increases this particular. You take the work in progress is 37. This one means the time is very less, and you have to the work in progress will be increases. Now assembly rate is take this one, and the corrected time is 60 days. The production is 360 and assembly 309 and finished inventory is this one and this. So coming to the what scenario we have to go for this one is see the moderate one is the inventory is moderate 12,244 units are there, and work in process inventory is 36,000 is there. Now coming to the assembly rate is 603. And coming to the graphs, see once suddenly the 10% increase of the orders, suddenly the hump shape is there, that will shows us the sudden increase of the production, the increases at the particular time. See this is the graph between the days, and this is the quantity, this one, and this is the order rate. So here this particular rate is 500 units per day. We are getting the orders, suddenly increases some percentage of the increase, the step increase of the productions, and suddenly we have to increase this particular the cyclic nature. Once around the 400 days are required to stabilize this particular process. And coming to the second graph, this is the status of the work in progress and finished inventory. Once the particular inventory is there, means work in process, blue line indicates the work in process, and this red line indicates that the finished inventory. So whatever the inventory is there, if the goods means you are getting the orders suddenly, the whatever the safety stock that will and it can be steadily down the particular time, which is 365 days. And so once the production is increases, the work in progress also increases. That will be stabilized at the around 550 days. This is the way we have to show the work in progress inventory dynamics. Now coming to the conclusions. The first conclusion is this paper is determines the model support the enterprise and measuring the state of performance under the increase in the customer orders, and the qualitative description is given by the causal loop diagram, and that is describes the whatever the process of this the process is there, whatever the process of the difference means the relationship between the variables we are described in the qualitatively. And coming to the quantitative analysis, stock flow diagram gives the differential equations, and you have to analyze the particular situation in a proper manner by the differential equation, solving these things in the simulation runs. There are three policy matters we are discussing here. Under the aggressive policy management responds quickly and adopts the changes in the business and tries to cut the inventory dispositions. But the condition is, if you are having the particular capacity or the particular enhancing the particular process or this particular assembly level, you can go for the aggressive policy in this one. And wherever the inventory holding costs are very high and should be maintained the inventory at the time. And second one is the slow policy management reluctant to correct the assembly rate immediately where the cost of changes are very expensive. That's why you have depending upon the company status, according to the order status, we have to decide that which policy we have to decide. So a moderate policy might be the characteristic of the organization, which will be cost holding inventories approximately at the cost of instability. That's why these are the three policies we have defined here. According to the situation of that particular company, they have to choose which policy is beneficial to the particular company. So these are the references we are used here. The CRP means this one is the system dynamics in the CARP journal, and this one is the system dynamics review. It is we'll say publications, and this one is the second one, and there the Stella package I am used here. This Stella package performance of this one is this is the package I use, and this is the system dynamics origin, this one. So please, any questions? Thank you. Any questions? Stop.
Okay, thank you very much for that very enlightening presentation. We have just one question for you. If you can, because it is a causal model. Hello? Hello? Yeah, are we online?
Presenter Rao, are you with us?
Hello? Hello?
Yes,
Hello?
he is, Taran.
Yeah, is he there?
Yes, he's online.
Yeah,
You can ask.
yeah.
Okay, just one brief question. If you can comment on the data set that was used, because it is manufacturing, was it different? Yeah.
Actually, I'm using the Stella software supplied by the iThink. So all these, what is the software that used in this particular data? It's Stella software. Stella software,
but the actual data itself, was it taken
taken from
systems?
data taken from the company. That is in one of the companies located in Hyderabad. They are manufacturing the medical disposables.
Okay. Thank you. Well, apparently, Sanjay, you want to take it from here?
Sure. Well, thank you very much. Thank you very much, Rao, for presenting and entertaining the question.